Today we're going to solve quadratic equations by a process called completing the square. Our goal is to take an equation, a quadratic equation, x squared plus 10x plus 25 equals 36. Let me fix this. And to force this side to be a perfect square. Notice that this one, it does factor to x plus 5 times x plus 5 equals 36. So we get x plus 5 quantity squared equals 36. So here we have the left side is a perfect square, or it's some number squared, and the right side is a constant of some kind. We can take an equation like that now and solve by taking the square root. But remember, when you yourself take the square root, you want all possible answers. So notice that I put a plus or minus here. Then we go ahead and solve that. The square cancels the square root, so we get x plus 5 equals plus or minus 6. So we get x equals negative 5 plus or minus 6. So that's two different numbers. It's negative 5 plus 6, which gives us 1, and it's negative 5 minus 6, which gives us negative 11. So our two solutions are 1 and negative 11. Now this particular problem, we could have solved it by factoring because our answers come out to be real numbers. But there's some cases, remember when we tried to solve by factoring, where we couldn't do it. We would get what was called a prime, quadratic. So the process of completing the square allows us to solve those types of problems. So for instance, example, if I have x squared minus 12x plus 7 equals 0, there's nothing that multiplies to 7 but adds up to negative 12. So we would, if we were trying to do factoring, we would have to say that that was prime. Well, it's actually not prime. It is actually a irrational number. But if we use the process that's called completing the square, we can actually find the solution to this equation. So step number 1 is to take the constant and move it to the other side. So that gives us x squared minus 12x plus, and we're going to leave a space because we're going to add something here, equals negative 7 plus something. Because if we add something to the left side, we have to add that same amount to the right side. Now, when we're using the process of completing the square, the coefficient of the x squared term has to be 1, and it is already, so we don't have to worry about that. Then, the key number is the number in front of the x term, in other words, the middle term. What we do is we take that number, take the negative 12, and we multiply it times 1/2, which gives me negative 6. Okay? Now we take that negative 6 and square it, which gives me 36. And this is the number that we're going to add here and here. So we put a 36 in there. And then we're going to find that this is going to factor to x minus 6 times x minus 6. And then negative 7 and positive 36 is a positive 29. Now notice here that negative 6 was the number that we actually squared. So the number that we actually squared is what's going to go here. Now we can rewrite that as a square, and now we can solve that by taking the square root of both sides. So notice on the left-hand side I have a perfect square, and on the right-hand side I have a constant or some number. So now to solve that, I take the square root of both sides, but remember it's plus or minus on the right-hand side. And so that gives us x minus 6 equals plus or minus square root 29. Now finish off by adding 6 to both sides. So I get x equals 6 plus or minus square root 29. Now again, remember that's two numbers. That's 6 plus the square root of 29, that's one of my numbers, and the other number is 6 minus the square root of 29. That's the second number. Okay? Let's try another one like that. So example 2. Let's say I have x squared plus 8x plus 15 equals 0. And I want to solve this by completing the square. Step number 1, move the 15 to the other side. So I'm going to subtract 15 from both sides. Remember to leave an open space because we're going to find some number that makes this side a perfect square. But if I add some number to that side, I have to add the same number to the other side. So now we have to look for what number are we going to add here, right? And that number comes from this 8. So we take the 8, we multiply it by a half, that gives us 4, and then we square that number, which gives us 16. That is the number that gets added. Okay, so that gives us x squared plus 8x plus 16 equals 1. Okay, now we factor this side, but the factoring's easy because the factor is going to be the number that we squared. So it's going to be x plus 4 times x plus 4 because we squared a positive 4. Write it as a square. Now it's in the perfect form. We have a perfect square equals a constant, and now we take the square root of both sides. Okay, so x plus 4 equals plus or minus 1. Subtract 4 from both sides, so x equals negative 4 plus or minus 1. So that's negative 4 plus 1, which is negative 3, and negative 4 minus 1, which is a negative 5. So my two solutions are negative 3 and negative 5, which tells me that I could have solved the original problem by factoring, because I got integers for answers. Okay. All right. One more like this. So again, notice that on all three of these examples that I am doing, the coefficient of the x squared term is a 1. Okay? And so when that's the case, and I want to solve by completing the square, all I have to do now is move the constant to the other side. So I'm moving this over here. Then remember I leave a space because I'm going to add something specific. Okay? But if I add something to this side, I have to add the same amount to that side. So now the goal is, what is it that I'm going to add right here? So where does that come from? That's right, it comes from this negative 18. We take the negative 18, multiply it by a half, or divide it by 2, gives us negative 9, squared gives us 81. So that is the number that gets added here and here. So I'm going to have x squared minus 18x plus 81 equals, what is that, 45? Yeah, 45, positive 45. Now the next step is to factor this, but remember the factoring is really done for us because that tells us what the factor is. So it's going to be x minus 9 x minus 9. So we squared a negative 9. So x minus 9 quantity squared equals 45. This is the exact form that we were looking for, because when it's in that form, we can solve by taking the square root of both sides. Remember, it's plus or minus on the right side. And this is really 9 times 5, so that's 3 square root 5. Add 9 to both sides. And so we get x equals 9 plus or minus 3 square root 5. So one of the numbers is 9 plus 3 square root 5, and the other number is 9 minus 3 square root 5. Those are our two solutions. All right. Now remember the step that says that the number in front of the x squared must be a 1. So what do you do when it is not a 1? All right. So for instance, example number 4, if I have 2x squared minus 6x plus 8 equals 12. Okay. Well, what I want to do is first of all start off by, again, moving the constant to their side. So I'm going to subtract 8 from both sides. So I have 2x squared minus 6x plus something equals 4 plus something. Actually, let's go back and let's do this way. Okay, remember that we don't want this 2 here. So let's go ahead and get rid of that by dividing everything by 2. All right, so that gives us x squared minus 3x plus 4 equals 6. Okay, now let's go ahead and do the process. So move the constant to the other side, so I'm going to subtract 4 from both sides. But leave a space because I know I'm going to add something. 6 and negative 4 is 2, but I want to add something. Then remember that you take the coefficient of the x term, multiply it by a half, and square that, so we get 9/4. So the number I'm going to add to both sides is 9/4. Okay? Which means I'm going to need to change this 2 to 4, so I'm going to multiply top and bottom by 4. So that's going to give me x squared minus 3x plus 9/4 equals 8/4 plus 9/4. So it's x squared minus 3x plus 9/4 equals 17/4. Okay? Now I'm going to take this side and factor it. But remember, I forced it to be a perfect square, and the number that I squared is what it factors to. So it's going to be x minus 3/2 times x minus 3/2 equals 17/4. Or x minus 3/2 quantity squared equals 17/4. And remember, this was my goal, to get it written in this form. A perfect square here equals a constant. Now take the square root of both sides. Remember, on this side it's plus or minus. Okay, so then that's going to give us x minus 3/2 equals plus or minus the square root of 17 over 2. Add 3/2 to both sides. So x equals 3/2 plus or minus square root of 17/2. So my two solutions are 3 plus square root 17 over 2. That's one of my numbers. And the second one is 3 minus square root of 17 over 2. Okay, so let's try another one. 3x squared plus x minus 6 equals negative 5. So first of all, we don't want this coefficient, So the way to get rid of it is divide everything by 3. So that gives us x squared plus 1/3 x minus 2 equals negative 5/3. Alright, now I need to move this constant to the other side, so I'm going to add 2 to both sides. And I'm going to add something here. I have negative 5/2, 5/3 plus 2 over 1 plus something else. Okay, so what is it that we're going to add here and here? Where does it come from? It comes from this. So we take that, multiply it by a half, that gives us 1/6. Square that, gives us 1 over 36. So I'm going to add a 1 over 36 and a 1 over 36. Okay, then that's going to be x squared plus 1/3 x plus 1 over 36. And my common denominator here is going to be on the right hand side. Looking at the denominators is going to be 36. So I need to multiply this top and bottom by 12. So it's going to be negative 60 over 12. This top and bottom by 36. So 72 over 36 plus 1 over 36. Oops, I messed up here. 3 times 12 is 36. Right? So then it's going to be x squared plus 1/3 x plus 1 over 36 equals negative 60 plus 73 over 36. So that's going to leave me a positive 13 over 36. Okay, which reduces down to, well, it doesn't reduce, okay? So now we're ready to factor. So what does this factor to? What did we actually square? Remember, we squared a 1/6. So this is going to factor to x plus 1/6 times x plus 1/6 equals 13 over 36. But that's really x plus 1/6 quantity squared equals 13 over 36. Now take the square root of both sides. And so I get x plus 1/6 equals plus or minus square root of 13 over square root of 36. Simplify, we get this. Subtract 1/6 from both sides. So x equals negative 1/6 plus or minus square root of 13 over 6. So my solution is negative 1 plus square root 13 over 6. That's 1 answer. The other answer is negative 1 minus square root 13 over 6. Those are my two solutions. Right, let's do one more. This is going to be example number 6. So I have 4x squared plus 9 equals 12x. Now take a minute and look at this. What's wrong with this at this point? Right, so we need to move this to the other side. Okay, now we want to solve this. So we want to solve it by completing the square. What is the first thing we should do? That's right, we need to get rid of this 4 because we cannot complete the square if there's a number other than 1 in front of the x squared term. So what we're going to do is divide everything by 4. we get x squared minus 3x plus 9/4 equals 0. Now, what's the next step? That's right, move the constant to the other side, but leave its space open. So I move it to the other side by subtracting 9/4. Okay, but if I add this to this side, I have to add to that side. All right, now, how do I figure out what to add right here and right here? How do I figure that out? That's right, we take the -3, multiply it times a half, which gives us -3/2, square that, it's 9/4. So we're going to add 9/4 here and 9/4 here. Okay, so that's going to be x squared minus 3x plus 9/4 equals 0. Which means that we could have factored at the very beginning. It would have solved by factoring. But we know that the left-hand side is going to factor to x minus 3/2 and x minus 3/2, which is x minus 3/2 squared. Take the square root of both sides. But plus or minus 0 is just 0, and add 3/2 to both sides. Okay? Which means that when we get just one number like this, this means that it would have been a double root. So in other words, that 3/2 is a root twice. So this is a double root.